Hey guys, it's Daniel here. I'm the mechanical engineer on the AltMill project here at cncilabs. So you might have heard about this from our other videos, word of mouth. This is actually a very old project that dates back probably like 2.5 years ago. Originally it was just kind of a plate design with some round profile type linear rails. It's evolved quite a bit from that. We built our first prototype, had some concerns, issues, kind of just redesigned this knowing new things we know now. And today we're here to talk about the prototype. Very exciting. We have pretty much everything here ready to go as our prototype machine. Small things will change for production since we are in production for this machine, but very minor things. This is very much replicative of what you'll end up getting with the AltMill. We can kind of just dive in and talk about some of the stuff that maybe you didn't get to see in our last video. First of all is the machine itself, or rather I guess like these fancy big parts, giant extrusions. We talked about these, but they're here now. Big Y-rail extrusions, our table extrusions are all here. So we've got our table frame built, and then also table legs. This is standing on its own legs now, which is exciting, fun to see. And it moves, it's all wired up. It's performing better than we expected. Pretty promising results so far. And then the other small prototype parts we have are all the plates for gantry assemblies, things like that. Again, these are gonna change slightly, but they are very replicative of what you'll get and how the machine will perform. We can talk about some of the other features maybe we didn't discuss last time. So we have now tram adjustment and knot adjustment that we'll have for this machine. You won't have to be shimming anything around or fiddling with anything. It's going to be kind of simple, and that's generally expected on a sort of industrial-ish machine. Table legs are great to have. We have a small set of holes you can kind of see to mount your own kind of 2x4 or any kind of material shelving unit. You have a lower shelf set up here, and you also have holes for setting up a second higher up shelf. You can use that to put your tools, something like that. And the lower shelf is great because it clears a 49-inch wide sheet. So you can cut your 4x4 sheets and store them here, use those to process or bring them up to the table and cut some stuff out. It's really handy to have. Closed loop stepper motors that we discussed in our last video. These have been performing fantastic as expected. They're all set up on all axis here, so we'll give you a little bit more demo of that. The other thing is limit switches are all kind of set up now too. Those are going to be a standard option, or a standard item I guess, at sale. So previously with a long mill, we've always kind of taken the stance of you probably don't need them, and it's true, you generally probably don't need them. It's just one of those things that helps with reliability. If you're doing a lot of jobs or very expensive materials and you really need that security and you're willing to kind of take that dive and figure out how they work and what they do. So for this machine, it's a little bit more advanced. We've opted to just include those as default. And they also kind of help serve some protection for the machine. It's a very, very powerful machine, and it's capable of kind of doing a little bit of damage to itself. So they're nice to have there for that. Generally an overview of the machine, what's here today, and we'll kind of dive into the specifics. We can start with the X-axis extrusion. So we talked about this last time. It's just a giant, big, beefy rail. This is ginormous compared to the long mill X-axis rail. And something we talked about in the last video was with the switch to now very robust linear rail system, we really needed to upgrade everything else on this machine to make sure nothing else was going to be the bottleneck. We want to keep every component balanced as far as where deflection comes from. The main suspect for that usually is your X-axis rail. It's a long spanning 4 foot, well, longer than 4 foot wide beam, and it kind of needs to resist a lot of torsion in the center, a lot of bending, miscellaneous things like that. It's been sized correctly for that, and in our testing now in the real world, it's proven to be super rigid. Our linear rails mounted, these are machined with reference edges for alignment, etc. All of that will all be handled by us internally when we pre-assemble the X-axis, and you'll just have to bolt on the Z-axis to itself. From the factory or from assembly, you shouldn't really need to adjust any tram. The Z-axis squareness with the X-axis is kind of located already by some very precise fit holes, and it should kind of just line up on the first try. As we've mentioned, there's options to adjust that if you need to, if there's, for some weird reason, you want very, very crazy accurate tram. Other than that, the Z-axis is pretty basic, just some plates, and you'll notice we have a spindle on this. We mentioned in the last video as well, this machine is very, very capable, and the long mill and other similar size CNC routers are usually the bottleneck for typical trim routers like the Makita. In the case of something like this, you start to step up and you see machines in this kind of class, they typically have spindles or even more powerful spindles than this one. For instance, this 2.2 kilowatt spindle is actually the bottleneck for this machine right now. I've been doing some cut testing and it can outperform that spindle. So next we can talk about these gantry plates. These are very beefy, but oddly enough, they're actually going to be even beefier when we go to production. So these are going to get just a little bit thicker. It's already very overkill, but it's kind of better to err on the safe side. So you'll mount your gantry by just kind of dropping this in, and we've got slots where you can catch screws to help locate that. We definitely recommend assembling this with 2 people, maybe even 3 if you have someone around, but it's possible to do it with 1. I know this because I did, just not recommended. So you can just kind of drop this entire assembly in here and you're good to go. Everything is kind of adjusted on the first go and you don't need to tinker too much with adjusting for your tram or not. And then these are the Y-axis extrusion rails that we talked about last time as well. These are all good to go. Again, these are pre-assembled with the linear rail and ball screw mounted by us. You just have to put these onto the frame and continue from there. The table extrusions, you can't really see them. There's 5 of them under this wasteboard. So we can talk about the integrated closed loop stepper motors over here and on all the other axes. These essentially are able to keep track of their own position, and if they detect that position has fallen off, it's off by 1 degree even, some tiny amount, it's able to automatically self-correct for that. If you run into an end and it's stuck in a position, it'll send an alarm signal. The controller will shut everything off to make sure no damage is done and that you're aware that something wrong has happened. As opposed to open loop steppers, which are pretty much on any other hobby CNC kind of router, you generally will skip a step or lose position and you kind of are lost after that. There's not much you can do and you might not even realize that it happens. So that's the annoying part. These are very powerful motors. So with closed loop, you don't just get the position tracking, but you also get a little bit more performance out of these. They can do all kinds of fancy field-oriented control things and reach higher speeds than regular motors, but that's a whole rabbit hole on its own. The summary is basically they're very powerful, they can go very fast. These motors are going to be connected to the controller and brings up the topic of how are we controlling these motors with the super longboard. So the super longboard we're going to be using for this machine isn't actually the original same long mill variant of the super longboard. 1, because that has its own drivers and we don't need those. It's kind of unnecessary cost that we'd be tacking on. And 2, because we need external driver support with that board. Essentially, this modified variation of the longboard, super longboard, will have external driver output and feature all of the power circuitry needed to feed power to these motors individually, as well as some other kind of AltMill specific things. But I guess for the most part, it's essentially just a super longboard with no drivers, external driver support, and some power stuff going on so that we can make this happen. So you can expect all the same general functionality with the super longboard from the long mill / what you may have heard more about as with this. So you'll have any of the other fun Grobel HAL specific kind of features. We talked about in the last video, there's a lot of outputs, there's a lot of functionality for things like tool changing in the future. It's got support for the external e-stop with macro buttons, things like that. And basically anything else we develop for that on the firmware or hardware side will all be compatible as well. That's about all there is for the control side. Electronics, it's pretty simple. It's going to be a 48 volt system though. So long mill has traditionally been 24 volt. 48 volt kind of helps bump up our speed since we're able to go much faster now. Going to be 1 plug going to your wall and it's done. The other thing we can talk about now is the accessories and kind of add-ons for this machine. It's not really an accessory because we plan on actually having this as a default configuration, but there will be shields covering the Y-axis. So kind of a similar sort of thing as our long mill's lead screw covers. We offer stainless steel dust cover for that. These will be kind of a default option. So they'll cover the entirety of the Y-axis, protect your ball screw, protect your linear rails from any dust and stuff like that, as well as kind of help to keep this drag chain in place. Dust shoe stuff is going on right now. So one of our engineers, John, is currently designing that, and that should accommodate a variety of spindles, things like that. Makita, of course, anything. And obviously touch plates. So we have the Auto Zero touch plate, the standard touch plate will all be compatible. Nothing's really changed with that. The Vortex rotary axis, which we already have for the long mill, will of course fit with this machine. This is an even taller gantry, so it will clear even larger stock diameters, things like that. And of course, integrating that with The new super long board will be even easier too. You can just have true 4-axis control. And obviously the laser beam will fit this as well. This is actually going to be very nice to have the laser beam on because this thing can really move. It can travel extremely fast. So when you're doing nice long raster engravings, time is going to be cut in half or probably more depending on what you're doing. We can talk about some of the specs of this machine. Obviously we mentioned it's a 4x4 cutting machine, so 48 by 48. We actually have the maximum travels with a little bit more buffer. We do that with a long mill as well. Just kind of make sure you can fit stuff in those weird scenarios where you need that extra 1.5 inches or something. The x-axis travel is about 50 inches. The y-axis full travel is about just over 49 inches. The height under the gantry, 5.5 inches tall. So you can fit your giant slab, tree trunk, whatever you've got. Like I mentioned, that also helps with vortex, kind of just clearing some of those taller things. The z-axis travel is just about 6.5 inches. As far as the actual speeds, spec-wise, we're still doing a little bit more testing to kind of finalize that, but you'll see us later running this very fast, and we'll talk about that more. We are able to run this quite comfortably at 630 inches per minute, roughly. And the machine can do that very comfortably, but we'll likely have to sort of detune that. It's a little too aggressive, a little scary. It can also accelerate much faster. So I'll show you a quick little demo. It's pretty quick. The table height for the machine is currently set as 34 inches. Obviously that doesn't include your wasteboard or kind of anything else you might want to put on top, so you could build up a higher T-track system. But 34 inches is kind of an arbitrary choice, both because we want the machine to be low enough that you can reach across. Something you don't realize with a really large machine like this is that you really need it to be lower than you to be able to reach to the back. Like, I'm pretty tall, and it's kind of still a struggle to get even halfway across the machine if you were holding something down or setting up a piece of wood. If you wanted, you could probably put some kind of casters or some kind of feet on these legs as well, lift this up, or vice versa. You could probably cut these down if needed. On that note, I guess we also have leveling feet on the table legs, so you'll be able to compensate for any kind of wonky floor on your garage or any kind of cracks and things like that. Keep the machine stable. Those are rubber feet, so they kind of help to absorb some of the vibrations as well. So we'll talk a little bit more about spindles. We mentioned in our last video, this is a very capable machine, and it would kind of really suck if we didn't have some sort of spindle option to allow you to actually utilize the rigidity and speed of this machine. We'll likely have some kind of VFD spindle option. I guess related to that is the router mount / spindle mount. So this is just a random prototype kind of router mount. We will be developing our own 80mm router mount that will be more appropriate for the spindle type and the extra rigidity needed. So that'll be a little bit taller / wider and generally just more rigid. If you're using the Makita, we'll include the standard long mill used 65mm router mount, and that will just mount in from the back, very similar to what we do right now. We kind of suspect a lot of people probably won't want to use a Makita. There's nothing wrong with it. It's probably the better choice if you aren't going to be hogging out material non-stop and you kind of just want something that can stand in for you either while you're getting started out or just doing lighter cuts and smaller detail work. It's totally fine. And the last related thing to that, I guess, is drag chains are now much bigger. The long mill ones are, I think, about half or maybe a third of the size of these. So this will allow for our motors to get their power and signal cables separately, as well as potentially if you were plumbing your own water-cooled spindle in, those lines would probably fit in here fine. So we've had some small delays just from random QC issues on small parts. Those have all been figured out and everything's in full steam ahead now. We still are aiming to have our pre-order open sometime in the end of March. If you are interested in the AltMill, obviously fill out the ordering survey to kind of let us know your interest and sort of keep your spot in line. Make sure you're subscribed to our newsletter so you can kind of keep up with any updates, any new developments, any of our timeline as that continues to get more refined. Some of the other challenges that kind of we're still in the midst of processing and figuring out are just the assembly, all of our in-house assembly. This is a giant machine. This is a very big challenge for us. So that's going to take some time to get ironed out. Packaging, stuff like that, and shipping, getting you guys some more information on that. So there's a lot of logistical challenges that are very different from what we're used to with a long mill, this being a much larger machine, much heavier machine. The last thing, which is the pricing for this machine. This is all very to be finalized, and this is just a more refined estimate of what things will cost. The AltMill machine base itself will be around $2,800 USD. Table legs might be around $150 USD. The spindle with VFD kit for the machine might be around $450 USD. We really wanted to pass on some of the savings we were able to make to the customer and offer this at a low price for this class. And we're kind of toying with the idea of doing the similar thing to what we do right now with the long mill, which is offer a beginner's kit, and this might be a bundle of all of these sorts of components just to get you started. Things we aren't including with the machine, basically the only things you'll need are a waste board to set up this table and obviously a computer to control the machine. Installing this table is pretty simple. You can go in from the bottom and screw in using small wood screws through the extrusion up into the waste board. You can also mount this down from the top using the T-slot in the extrusion. So there's a variety of ways to do this. We have here shown the standard T-track we have, and this is very similar kind of setup is what we do with the long mill. Pretty simple, just MDF, and you surface it and you get a nice planar surface. So we've talked a lot about rigidity for this machine and kind of what a machine in this sort of class should be able to do, and the upgrades with linear rails and some of the thought put into this other extrusion, etc., the whole machine. And rigidity is kind of one of those things that it's a little weird. Like, people tend to look at one machine and they'll say, oh, this looks very beefy. I mean, this machine looks beefy too, but you should kind of not take everyone's word for that and actually sort of try and look at it quantitatively. So today we're going to look at the actual measured rigidity of this machine and kind of actually put out some numbers. Imagine buying a car and no one really tells you how much horsepower it has. It's just, oh, this Corvette looks like it goes fast. We're trying to address that a little bit. We've put out in the past, I think it's like a 40-page report on deflection testing for the long mill. We've made videos in the past talking about this, testing, showing numbers. I don't know why no one else really does this, but we'll take the opportunity today to talk about that here on this machine, since this is kind of a main feature of a more industrial-ish machine. So we've got this little setup here. This is just a dial indicator checking the deflection in the y-axis direction. Our spindle is located in the center of the table, in the middle of the x-axis, and this is generally considered the weakest position for it to be in. Obviously, because this is in the middle of this giant beam, it's now going to bend across this entire length. So you generally want to check for the weakest position where you'll see the most deflection, and that's what we'll look at today. We've got our dial indicator set at 0. We've got this handy little force gauge. A lot of our testing, we've used 80 newtons as a standard general cutting force estimate to try and read that out. So we'll just set this up on our bit here, and we'll just give this a pull until we see 80 newtons. It's about 80 newtons. And you can see we've got deflection about 3.5 thousandths of an inch. And then the other fun thing you can do from that is you can take those numbers and calculate your general rigidity coefficient. And this is really the number that you're kind of curious to know, or like you should be curious to know. And this is just generally how much is your machine going to deflect for a given amount of force. The industry standard for that in higher end CNC mills and stuff tends to usually be like a newtons per micron as your unit. These numbers are kind of meaningless, but you know, we'd like to put them out there and kind of quantify and actually like back up saying this is rigid. Don't just take our word for that, just look at the numbers yourselves and make your own decision on that. Yeah, we'd love to see other people kind of come out with their own findings. If you have a different machine at home, like, it's kind of nice to compare something and just make this industry excel a little bit more as a whole. So those numbers we actually have tested on our prototype machine for rigidity coefficients are 1.05 newtons per micron in the y direction, and then 1.26 newtons per micron in the x direction. Those are basically the only two really important numbers. And as I mentioned, that will be even more rigid if you go to front left corner, back left corner, etc. Any of the corners. This is checked in the weakest position with the spindle lower down to about table height. That's kind of, I guess, the proof in the pudding. We've done our homework. It's worked out great. Those numbers, without any context, don't mean much, but they're very good. We'll just check out some of the kind of speed capabilities of the machine. Like I mentioned before, this can do about 16,000 millimeters per minute. We're obviously not going to always want to be doing that, so the machine might ship with some lower default speed, but we'll kind of just run a little quick program, show you what that looks like. essentially what the machine can do. We, like I said, will probably tune that down a bit. It's kind of shaking violently, so it's a little bit excessive. And frankly, not many people need that kind of speed, but kind of probably have some more updates on what this looks like as we continue testing it and do some more cuts and projects as we go on.